All right, so we're going to get a little bit more practice with naming and formula writing for ionic compounds, including some transition metals and also including some polyatomic ions in some cases. So you need to get your periodic table out, and then you can write these examples in your notes. This is actually the quiz that I was originally going to give in class last time, but I decided to go ahead and use it as practice, and then I'll give you a very similar quiz the next time we meet. So this will be good practice for that. And of course, the better notes you take over the practice you're getting right now, it's going to be an open note quiz. So the better you're going to do on that quiz. All right. So again, it's not going to be exactly the same problems, but it's going to be very, very similar format, very similar problem types. Okay. So when we're looking at an ionic compound, like number one here, FeCl3, we first have to decide whether the metal, in this case the iron Fe, is a transition metal or not. Because if it's not a transition metal, we can tell what its charge is just by looking at where it sits in the periodic table. And if it's not a transition metal, then we don't really need to include the charge in the name. In fact, we shouldn't include the charge in the name if it's not a transition metal. So iron, though, and again, you should have your periodic table handy for this, but iron, Fe, is right here in the middle of the transition metals. It is a transition metal, and it's not one of our exceptions. The exceptions, you should have written this down in your notes already, but here they are. Silver is +1, zinc is +2, so is cadmium, aluminum, gallium, and indium are all +3. So those are transition metals that we don't necessarily, or that we don't include the Roman numeral for because they're always the same charge. Iron is not one of those exceptions, so we need to include the Roman numeral for the charge. So how do we figure it out? Well, if I have FeCl3, first I look at the charge on the chloride, and based on its position on the periodic table, which is right there, we know that it has a -1 charge along with everything else in group 17. So if this is -1, and I have 3 of them, that's a total of -3. So if the total charge on the whole compound is 0, which it always is, then we would have to have a +3 charge coming from the positive side. And since there's only one iron here, that means that this one single iron has to have a +3 charge so that it balances out. So with all that having been said, and knowing that we have to include the Roman numeral, what would you call this compound? Okay, you should have said that this would be called iron 3, the Roman numeral, chloride. Okay, and just like always, don't forget the "ide" ending. Anytime you have an element from the periodic table, a nonmetal from the periodic table, we always want to give it that "ide" ending. Okay, let's look at another example, BaOH2. So again, what do we do first? We look at the positive ion. If it's a transition metal, then its charge is going to have to be included in the name, just like charge 3 was included in the previous problem. Barium, if we look at the periodic table, is down here. It's in the S block. Everything in S block is always +2. Okay, so we will not be including the Roman numeral because it's not a transition metal. We do have a polyatomic ion here, hydroxide. And the good thing about polyatomic ions, and again, you're given the list of polyatomic ions. You don't have to memorize that. Okay, so here's hydroxide. The good thing about the polyatomic ions is you don't have to change their names at all. You don't have to do anything to them. You just have to leave it as is. So this one is going to be called barium hydroxide. So again, we did not add a Roman numeral. Why didn't we add a Roman numeral? Because it's not a transition metal. It's in group 2. Okay, so everything in the S block, which is this stuff over here, plus the 6 metals that we talked about, aluminum, gallium, and indium are +3, zinc and cadmium are +2, and silver is +1. So it kind of makes a little staircase. So all the metals outside of that staircase or outside of the S block are going to be transition metals and need to have a Roman numeral. But barium is not, so it doesn't get a Roman numeral. Okay. Let's see if you can work through this next one a little bit more on your own here. So if I have copper, and I have 3 of them, and phosphate, and I have 2 of them, is copper a transition metal? Yes, it is. So we're going to have to include a Roman numeral because it's a transition metal and it's not a part of that staircase, so we're going to have to include the charge. We have to know the charge on phosphate. We have to remember that's -3. Okay, or we don't have to remember it. We can look it up, right? It's right there on the page. So if that's -3 and I have 2 of them, then that's going to give me -6. The total charge of my compound has to be 0. So that means the coppers over here have to total +6. And if there are 3 of them, we're just going to divide 6 by 3 and get the charge of the copper. So what would that be? Okay, so this must be copper with a 2+ charge. So then what would the name of the formula be? Okay, so you should have said copper 2 phosphate. All right. You can try those others for practice. I'm going to jump down to the bottom of the page here and look at some formula writing. Let's look at number 7, aluminum sulfite. So the first step is going to be to write out the ions with their charges. So sulfite is SO3 with a 2- charge. Aluminum is not a transition metal. It's up here in the P block and it has a +3 charge. So aluminum is always +3. That's why it wasn't. That's why the Roman numeral was not included in the name. So aluminum is +3. So what do I do when I have a +3 and a -2? I have to find the least common multiple. So what is the least common multiple of 3 and 2? Okay, it's 6, right? So how many aluminums, if each one is 3+, how many aluminums would I need to get a total of +6? All right, so you should have said I would need 2 aluminums. And then sulfite. Right now, you have to understand, this is just one sulfite right now. And it has a -2 charge. But to cancel the +6 from the aluminum, I need -6 from my sulfite. So how many sulfites at -2 apiece would get me to -6? So you should have said 3, right? Because 3 times -2 is -6. Okay, and then 2 times +3 is +6, and that does total 0. So my formula, I know I've got a lot of stuff here, but the formula is Al2SO3 3. Okay. All right, let's try one more of these where you're writing the formula. Platinum, and that is the Roman numeral 4 sulfate. So platinum is on the periodic table. It is PT, and the Roman numeral gives me the charge. So I don't have any figuring out of the charge, or I don't even have to look at the periodic table. The Roman numeral tells me that this is a transition metal and its charge is 4+. Okay. Sulfate is one of my polyatomic ions from down here on the bottom of the page. So here it is. It's very similar to sulfite, only this time it's SO4 with a 2- charge. So SO4 and 2-. Okay. So then what we have to do is think about least common multiple again. So what's the least common multiple of 4 and 2? So it's 4, right? So we don't need to have any more platinums because it's already +4. But I need to get to -4 with my sulfate rather. So I'm going to need how many of those? -2 times what is -4? All right, so you should have said 2. Because 2 times -2 is -4, and that's going to cancel the +4 on my platinum. So I have 1 platinum and 2 sulfates. And kind of out of room here, but if I were to rewrite it a little bit more neatly here, PT and then SO4 in parentheses 2. So that would be platinum 4 sulfate.